Hey, welcome to the video. Recently purchased a Velux Solar Skylight kit, and it comes with this controller. It's the KLI 310, as far as I'm led to believe. And naturally the first thing I decided to do was to see if there's any app control or voice control for it in Google. And there is, Velux do sell their own little kit. That's about $500 Australian, which is pretty pricey. I did ask the Home Finance Committee about it, but that's my wife, and the answer was simple no to that. So I started looking around for other different things. There are some third-party controllers out there, but similarly priced and very expensive. So I thought, can we do this in another way? So yes, you can, and I believe you could do it for less than $30. And I'll show you in a sec how to do it. Now, I've actually used one of these before in another house that we had with these controllers and stuff like that, before all the third-party app control stuff came out, and they're pretty neat. They operate, as far as I'm aware, on about 888 megahertz. They use their own little specialized controller thing, so you can't really copy these remotes. You can't do too much to them, so I think the only way we're going to do is to break into it and then attach another controller, like a pre-made Google, Alexa, Apple type of controller. We're going to wire that into it, and that'll hopefully get us going with it. One of the things that I have used in the past, and that works pretty well, is this little self-locking Wi-Fi switch relay. You can purchase these for about $16 Australian, roughly delivered. I got this one for about that price, and it's pretty simple to set up. It uses the eWeLink app, and it works pretty well. And that allows you to have Google, which I'll be using Google or Alexa or Apple control to it, and it'll switch a relay on and off as you command it to do that. So it's pretty neat little gadget, and pretty cheap for about $16 odd. So we're going to get that wired into this. So how do we do all this? Okay, now before we start, pretty conscious that most people watching this won't be able to make and etch their own circuit boards. That sort of gets a little bit more technical than most people might be able to do. So I would really try to keep this really simple. I did look at timer circuits and microprocessors and so forth, whatever, which is something I could do, and it's pretty snazzy to do that, and it looks really great once you've built it and it all comes together. But like I said, most people out there, 99% of people won't be able to etch a circuit board, put a microprocessor together, or get a circuit put together and so forth. So I really wanted to go back to some old school, simple, very reliable stuff you could go down to your local electronics shop and buy for, like I said, less than about $30. Even parts here will be even less than that, about $15 odd. So let's start with the controller. So simply pop it open on each side, goes like that, and once you've popped it open, you can see inside there's a small little circuit board, main IC controller, and a couple of buttons in there, and the batteries that obviously sit in there, and you can pop this open relatively easily by pulling these two little tabs back, like so. That's the circuit board side, and on the back of it there's three switches there, which is the up, down, and stop. We're not going to be using the stop, we're going to be using the up and down. Now there's two ways to do this. If you've got your own controller, we can actually solder the wires to the IC points, and that'll be our up and down command for the little controller to operate. If you had a spare one of these, and you can buy these for about $50 odd, that some people sell secondhand or not aftermarket products, but simply just have excess stock. New, they're about $150, so gets a little bit pricey in that. But if you wanted to buy a second one of these and shove it in the cupboard somewhere out of the way, and you can still keep your own existing controller, you can actually then just take these off and solder it directly to these points here. So if you're not going to be using your own controller and you're going to get a second one, you can actually just solder it here. It's a lot easier. Otherwise we'll be soldering it directly to the IC with just three little points. It's only two to the IC, one is going to be a ground point, and then we'll wire up to the controller. So let's get to the soldering. Okay, the first one we're going to solder is the ground point here, which is this one here. We're going to take a little dab and get this wire, just tin that a little bit, and same thing, we're just going to tap it on there, and that's done. That's one point. And now we're going to do the other 2 points, which is for the up and down points on the IC. You do need a very fine little soldering iron to get that. Unfortunately, those pins, there are no other contact points that I can sort of really run to because they run off to the other side. So I'll show you that in a blow-up diagram, which you'll most probably be seeing now on your screen. As I said to you, other option is to actually remove this tape off here, and in these you can peel these little off and solder it directly to this. The only unfortunate thing is with that, if you're going to use your own controller, you're really going to struggle to use this again on this controller, because obviously you're going to interfere with this pad here for these buttons, so then this will become obsolete. But if you didn't want to have this on the wall, you wanted a full Google or Alexa control, then you could certainly just solder to these points. It's a lot easier, and this, like I said, could go in a cupboard somewhere, and you wouldn't have it, and you'd have full voice control without even this being on the wall. So that might be the easiest option for most people, is to peel this off, solder directly to these points. And there you have it after I've soldered it. See that? That's simply soldered to those points as I had on the video before on the stool shot. And as I said to you, if you did want to do it on this side, you'd simply peel off this plastic, remove these little metal switch covers, and you'd be soldering to the middle point on each one. So the middle one there and the middle one there, it's quite a nice little couple little print under there to be able to solder to. So the middle one and the middle one, and that there is your ground, and that'll give you, if you short out these two, it'll go down. If you short out these two, it'll go up. So the next thing is to wire it all up to the controller. So here's the controller we're going to be using. You can feed about 7 to 30 volts into here, so it's pretty flexible as whatever sort of DC power supply you have. This is your little Wi-Fi setup button, and there's a locking switch here to make it either a temporary on-off or a locking thing, so it actually locks either on or off as you do via the app. Now, the thing I've seen some people use these on other clips and stuff, and they have trouble with it actually clicking on and staying on and activating the button, but you need to release the button after about half a second. So the thing with these controllers is if you actually press and hold the button down, then it'll actually only operate until the time the button is pressed down, and as soon as you release it, it'll stop at that point. It won't actually physically open up or close the Skylight completely. So we need to work out a simple way to make this so when it actually clicks on and the relay activates, to actually momentarily only press the button and then release, and vice versa when we close the Skylight, that it actually momentarily presses the button and releases it to go all the way. So how do we do that? So we're going to use a simple little trick. We're going to use relays. As I said, very, very simple and easy to obtain. These are just simple 12 volt relays, and we're going to use capacitors. Now, the thing with capacitors, when you're with a DC circuit, initially when they're discharged, they act as a dead short. So for an initial period of time when you apply 12 volts to it, the capacitor acts like a dead short. As it charges up, it goes open circuit, and that's the trick to these. So we're actually going to use capacitors in series from the relay contact on the controller to these relays. So when it first charges up, it'll act as a dead short, the relay will close. After about half a second, it'll open up and the relay will disengage, and that'll give us our momentary contact of turning it on and off. Let's do it. As you can see with that still shot, the circuit, how it operates, it's very, very simple. As I said, you can just simply go and buy these parts for next to nothing almost, and put it all together. And you can see in the circuit that there's two relays there. One's going to be our up and one's going to be our down, and there's going to be a common, I'm using 12 volts in this case because I've got a 12 volt power pack. There's a common 12 volt rail that will feed into the switching relay in the input, and as it switches either up or down, it's going to give us 12 volts either on the one contact or the other contact, and that'll then provide voltage to the capacitor. The capacitor will then flow, the current will flow through the capacitor, turn the relay on momentarily, and then once it fully charges, it'll actually disengage, and that'll give us our up function, and the same thing with the other relay, it'll give us our down function. So as you can see, I've wired up these relays with the capacitors, and you also notice there's a resistor there. I'm using a 5.6 kilo ohm for these. Now this will vary depending on the size of the relay that you're using and the impedance of the coil itself. So the reason that resistor's there is to discharge this capacitor, so it's not holding the charge afterwards. So once the power's been released from the module that's providing the 12 volts that I'm using in here, then this resistor here will discharge this capacitor after a couple of seconds. So to demonstrate, so if you listen to the relay, as I apply 12 volts, you hear a click momentarily and releases. So as this capacitor charges up, for the first instant it's a dead short in there, the relay clicks on, and then as soon as the capacitor charges fully, it releases, and you've got your momentary contact. So once again, and a few seconds later, if you're opening the skylight and you decide to change your mind and you want to close the skylight, press it again, and you can open it again after a few seconds, and off you go. Very simple, very effective, nothing much to go wrong with it. And here we have everything put together. So we've got the controller, the two relays. I've added LEDs temporarily on them so you can actually see when they actually turn on and off. And I've also got the Velux controller here as well. So if I actually turn this on, you'll see the LED flash very briefly. And if I turn it off, it'll flash very briefly as well. So that's just showing you that there is actually power going to these relays, and they're actually activating, and what they're actually doing, they're actually simply turning, as they're turning on, they're momentarily making a contact for the up, and they're momentarily making a contact for the down, so it's opening the skylight and closing the skylight. So these LEDs will disappear later on. I just thought I'd add them in there so you can actually see it working, and as simple as that. The beauty of these two relays is for two factors. One, you're isolating this part to this. There is no actual physical connection to these because you're simply switching, using them as a switch. So you're not going to get any crazy earth loops or anything else once you add a power supply to this controller and upsetting it. Number two, very, very reliable and very, very simple. And three, because of these capacitors in here, you can actually make the relay a momentary contact. So the issue with these controllers is you can either turn the relay on or off. So you don't actually have a proper up and down function. With this, you can actually create your own up and down function or turn something on and off that's got two switches. So the way this works, you've got 12 volts going into the middle, and when it turns on, it shorts out these two contacts, which puts power through this capacitor to this relay, activates this relay for a moment, for a split second, and the two contacts go to the controller, and vice versa. When you turn it off, it makes contact here, power goes through the capacitor, turns the relay on momentarily, and shorts out the contact to actually go down. So you can turn the skylight to open or close, and in fact this part here, apart from the controller, this part back here can be adapted to almost any electrical appliance you have in your house. An air conditioner, your coffee machine, whatever you want to do, if you can tap into it, all you got to do is get these little wires connected and off you go. Okay, we're back inside. We're going to give this a bit of a real world test. You can see the skylight there reflecting off in the kitchen bench top, and we're going to go, hey Google, open Skylight. If you have a close look, you'll see the skylight opening up. And we'll change our mind now and say, hey Google, close Skylight. And see there, skylight's closing up. The job is done. All right, back in the workshop again. So a couple of final things to point out before we finish. You've noticed that I've used the battery still in the Velux controller. There's a good reason for that. I've had one of these controllers before in another house, and the batteries lasted for years. So I could have actually made up a little 3-volt power supply to run off the 12-volt power pack to get 3 volts down here to eliminate batteries, but hey, why reinvent the wheel? It works. Batteries, they last for years. There's no point. It makes it simple, it makes it easy. Secondly, the capacitors that I've used here, I've used 330 microfarad at 35 volt. There's no right or wrong with the values of these. Just a couple of things to point out is if you go 470 mic or even 1000 mic, it will leave this relay on longer, and it depends. These capacitor values depend on the impedance of this. So if you're using a bigger relay, you might have to use 1000 mic. If you're using a smaller relay, you might have to use a smaller value, but you don't want it to be on for more than about a second, otherwise then this doesn't become a momentary contact. It actually becomes a push and hold type of a contact, and that upsets the rhythm of the controller. So you can play around with these, and same as the resistors here, 5.6K I use for the discharge. You don't want to go down too low, otherwise when the relay activates, it'll actually remain on because current will be passing through that resistor. So play around with those, 5.6, 330 mic. They're the two sort of values for a standard small little relay. That'll work fine. Other than that, once you start doing this and perfecting it and it works fine, your first piece of equipment, I guarantee you'll start doing it to everything in the house, and you'll drive your wife nuts like I have. So everything is Google operated and retrofitted. I've got as I mentioned, a 20-year-old air conditioner that I've done it, and we just use it to death every single day. It's brilliant. You'll enjoy this. This is really fun to use. Very simple, very reliable, and for next to nothing. Yeah, have fun. Enjoy. And look, if you really like this video, hit that like button down the bottom. Helps me out. Have fun. Cheers.